but okay. That's lovely. I'll hit continue. All right, so
It's
anyway.
so weird now. I hate when it does that when you hit record. Now everyone gets a notification. I can't be sly about it anymore.
Nope, you can't slide it in. So whatever I say now, I know might go viral, so I'll behave myself. Anyway, welcome and greetings. I guess what I'll go ahead and do without any further ado, I'm going to go ahead and share screen. I will hit share. And voila, I think, I'd be remiss if I didn't. You guys can see my screen, correct? Yes. Yep. Excellent. So I think it would not be a great start unless I visited the Hurricane Center discussion. If you're geeks like me, everybody's been looking at their discussions. It's a nice way to sort of start things off. They obviously have intermediate advisories, but these are the 11 a.m. is more interesting than the intermediate at 2 p.m. So I'll go ahead and read through this real quickly because it kind of just gives the backdrop to the present state of affairs with Elsa, which is at the moment, as we now speak, crossing the country of Cuba, just to the south of Florida. So obviously, at least it's not a long flight for the recon. So, and you can see how they sort of start their discussion this morning here. So I guess I can just sort of, let me see if I can just get this going here. Hold on, Control A, I was hoping. Yep, so I'll start right there. You guys can see the little arrow. So NOAA Hurricane Hunter aircraft has been investigating Elsa while it approaches the south coast of Cuba this morning based on the step frequency microwave radiometer, otherwise known as the SFMR. They use these instruments. It turns out that step frequency microwave radiometer aboard the Recon can actually penetrate clouds. Sometimes it has trouble with really heavy precip, but pretty good microwave sensor. And so it can penetrate the clouds. Why do you want to penetrate the clouds? Because it'd be kind of nice to see essentially down to the low levels of the troposphere near the surface of the tropical cyclone to get an estimate of the wind speed. It's actually looking at the sea surface, an agitated sea surface. You have an agitated professor. This looks at an agitated sea surface. So anyway, so that's what that is up to there. And so I can not kill that. So exciting as center drops on from the plane measured 1,009 millibars. Woohoo. Try to contain yourselves. Now, it's not the minimum pressure that matters here, correct, guys? It's actually the pressure gradient, right? So it's really all about the pressure gradient, although hard to get excited about 1,009 millibars, to say the least, and 26 knots at the surface. Wow, now we're really getting anemic here. Anyway, nonetheless, basically, minimum central pressure, they adjusted downward a little bit. They don't explain why they've done it, but they've done it. And no significant change since yesterday. The tracks have been pretty dependable, actually, it turns out. They have a tail Doppler radar on board that Recon. And it turns out basically said that there was an eastward tilt of the center with height. Let me see if I can get that one to come back up. Okay, let's see, Control Q. Oops, you don't want to see that one come up yet. Sorry, that was premature. And now that did I actually get rid of that window now altogether? I didn't blast that out, did I? Where did I do with my, I love it. I just hit the wrong button and now I'm out of the discussion completely. Well, so that's weird. Maybe I just closed the window. Let me see if I can't find it. I've got plenty of stuff up here. I knew I would do this. I don't even know. Wow, really? I don't even know where that went now. I've got all sorts of goodies up here. Let me see, that's our splits diagram. You can tell Dr. L's got all sorts of goodies to show you guys, but now I think I blasted out complete. I don't even know what I did with my browser. Nope, give me a second. Good thing that we're recording. This is why I'm not a TV meteorologist, by the way. I've got a lot of stuff open. I thought I had it. Well, that's really weird.
I've missed this so much. This is literally what I've been waiting for.
Yes, you like the show already, even though I've all right. Well, I'm really not very happy about this. So I have so many goodies. I think I have enough windows open. I should have just stayed in at work today instead of coming home to do this. Would have been a lot easier. I'm sitting on one little laptop here. I know, don't feel sorry for me. And now I don't even see my browser, which means basically, I'm going to have to get out of there.
You have a lot of emails.
Don't even.
I have like 10,000 also, so you're not alone.
Let me hit.
Guys, that hurts my soul a little bit.
Yeah, hold on. Stop share. I'm going to go bring the share back. I'm looking for my Chrome. Hello? What the heck? Escape. Let me stop the share here for a second, right? Just give me a second. I mean, I really wanted to bring that back up. So let me bring the, I don't know what I did with the search. Sorry, guys. So in theory, I should be able to come back in here. There we go. Here we go. So no big deal, NHC. Let's try this again. All righty, so National Hurricane Center. Sorry, guys, I'll go back onto the share. Since Cassie's happy about it, I don't feel too bad. So we're back to the Hurricane Center. I really did want to go through the discussion. It's definitely worthwhile. Let's go back to the Cal Elsa and talk about the discussion here. And so, all right, back we go here. You guys can see my screen again. I am assuming that is the case, correct? So anyway, as we were saying, essentially, there's an eastward tilt, basically. Let me try this again. I tried it. Let me just, whatever. I forget which one is the, right, that's it, Control Q. And I was hoping to underline this right here. It's been a while. So there you go, eastward tilt of the center with height. So that's an issue. Storm continued to have some vertical alignment issues. So alignment is a problem for a tropical cyclone. It tends to have alignment issues if there's sufficient wind shear in the vertical. So these are issues. I will actually show you an IDV in a few minutes, what I think is the alignment issue. So I'll get to that. Anyway, it says satellite image continues to depict convective banding features over the eastern portion of the circulation. Somebody remind me if I have some time. I'll show you the radar as well. I did not bring that up, but it's starting to emerge. Some of the outer bands are starting to emerge in the Key West radar. So I'll be happy to show you that as well if I can get to that. Right. All right. Anyway, really the track motion really is nothing very exciting. The only other point I would make in here really ultimately, Joe and gang, is that basically you can clearly see it's going to basically over the next 2 to 3 days should move between a subtropical ridge over the southwest North Atlantic and a mid-level low over the northern Gulf of Mexico. In the latter part of the forecast cycle, Elsa is forecast to accelerate northeastward in the westerlies, right? So this is that whole curvature issue. As the storms gain latitude, eventually they interact with the westerlies, depending on where the sort of flow is situated in the continental US. Anyway, and I'll show you the trough that it's getting ready to interact with as it makes up latitude, okay? And so that's really the sort of the gist of it, since I spent so long messing with that. That's all I have to say about that component of the storm. And I'll shrink that baby down, and I'm going to go ahead and remind folks, now that I've done that twice, let's try that again. So let's move that away. So just a couple of reminders. I have a couple of things I can show you here. And a little thing about tropical cyclones. This is from a weather briefing class. I like to talk about these things in class so people actually learn something. And so on the left, basically, you have the sort of canonical storm structure. These are the bands here showing up here. So they're sort of little cartoon bands, right? And there's your eye, the warm core. And so when you look at this baby right here, that's the warm core. I'm going to show you guys the warm core of Elsa. Don't hold your breath, though. And so essentially pressure, these are profiles across the storm, east, west, north, south. They're cartoons, basically. So you can see a minimum pressure. The maximum wind speed essentially borders the, so that's these guys right here. So the peak winds around that. And, you know, when you fly recon, you can see these nice radial flights at one level, you can get to see these sort of cross sections of these storms. So these are pretty nice. And then some storm surge and temperature. And the temperature I really wanted to point out since I'm going to spend. So there's your little warm anomaly. You compare it to the ambient environment. Basically, this is basically an isotherm perturbed upward in that vertical cross section that we're looking at. So if you bounce over here, Cheryl and gang, basically, let me do that. And Joe, if you come over here, I took this from an article from Monthly Weather Review, which is really awesome. And I showed students this before. It's a climatology, basically, of temperature profiles in and around the center of circulation of everything from a tropical storm, which is the black curve, basically, all the way to Cat 5. They're stratified in rainbow colors. They're stratified by storm intensity, which is really awesome. And one of the take homes, we're looking at pressure. So it's pressure along this axis right here, up like that. And so that's the pressure axis. So what is the take home on the structure of these things? Really fascinating. For tropical, they are warm core features. And one of the take homes from the climatology here is that it looks like when you go from tropical cyclone, a tropical storm to essentially Cat 5, look at the temperature perturbations, these anomalies, right? If C or K, it doesn't matter since they're anomalies. We're looking at the most intense hurricanes can have warm cores that peaks somewhere around 300 millibars, which is about 9 kilometers here aloft right there. And so that baby right there is pretty impressive. That is, if you drop that down basically to the x-axis, we're looking at warm cores. Again, these are temperature anomalies from the undisturbed ambient environment around the tropical cyclones. So unlike mid-latitude cyclones, which are cold core systems, these are warm core. This baby, the climatology of a bunch of these Cat 5 storms, I'm assuming ultimately the person that did this study, I don't know the details off the top of my head, clearly had less Cat 5 storms than they had tropical storms to make these profiles, but these are composites basically on intensity. Anyway, look at the perturbation. That is quite a bit warmer. That's 12 degrees K or 12 degrees C between friends, and between friends you can multiply by that by 2, and we're looking at about 20 or 30 degrees warmer aloft in the center of the storms. The players in that process are mostly latent heat release from the condensation of the deep convection near the eye wall of the convection, but they're also subsidence. Compressional warming is also really important. And in fact, you can't get an eye really unless you really have some decent subsidence, which is going to basically cause the warming and drying. And oftentimes that's what opens up the upper level cirrus, the overcast, to a nice clear satellite presentation is that subsidence. Okay, so just wanted to remind folks of the nature of tropical cyclones and the nature of the beast there as well. I guess I could just use this figure to also to emphasize the fact that I'm going to show you basically a couple of different charts. I'm going to show you a 500 millibar chart, right? Just to remind you guys, that's 500 millibars. So we're looking at about 5.5 kilometers up in the atmosphere. And then I'll also show you guys some charts basically as well at 300 millibars. And so for the novices that don't think in terms of heights, we're looking at about 9 kilometers up. Okay, so just a quick overview on those two babies. And that is the end of my learning moment during weather briefing. And so I will go ahead and also shrink this guy down. And without any further ado, I am going to attempt to freak out the integrated data viewer. Anybody who's been to any of my weather briefings know I've broken this many times. And so we'll see what happens. You guys should be able to see. So let's just sort of start simple, right? And let's take a look at the presentation. I've got it in automatic update mode, and it's updating as we now speak. I can see my little wheel rolling. And I was threatening to turn the update off, but I loaded this app 2 hours ago, and I wanted to update my images while I was doing other stuff. So I was sort of threatening to turn it off before this started, but I decided, no, I want to punish myself. I'm going to let it just automatically update while I'm in the middle of briefing, and you guys are the benefactors. But anyway, it's been behaving fairly good. So let me go ahead then and put this baby in here. Let's take a look at the visible satellite presentation. And I forget where this starts and ends, but I'm going to go ahead and just step it forward. There we go. It certainly, as far as tropical cyclones is concerned, is not very exciting. How do I want to move this thing around? So let me just get rid of this down here. Okay. Anyway, so let me just play around with this a little bit more. Down, down, down. And do I have it on full screen? Doesn't seem to matter much. Okay. So, oh, it's updating again. Sorry. This is what I get for letting it do that. I know, Cassie, it's exciting, isn't it? Try to contain yourself.
I'm trying. I've missed this so much.
You too, Cheryl. Try to contain yourself. All right, and that bounce.
I'll do my best.
Yes. Again, I just remind folks this is why I'm not on air. We'll leave that to Joe. Boy, that's a warning, isn't it? Anyway, so will it go forward? Let's see. Oops. All right, so let me just put that in motion, and I want to zoom in on this baby and come on south a little bit. I could make it a little bit better quality here, but that looks like we are done with the extent of the animation in here. So let me come back and so this, okay, so it looks like I have 2 hours on here. These are 5 minutes apart. So this is basically, you can actually see the time up here maybe. So that the little time stuff is up in here. It starts at 1711. So that's about 111. So it's going to go from about 111 to 311 on the animation here for you guys. And let me clean that up again. So I'm going to just step through this. Well, I'll just let it go. So you can actually see a fairly nice band here. Oops. It's reloading, I guess, apparently. So here we go. It's reloading. It's reloading. I really should have shut this off. You can see my wheel. See, I have evidence. It's definitely my wheel is going. Could you imagine me being on TV and doing this? I could just tell the audience, hey, look, my wheel is rolling on my Macintosh, right?
To be fair, you probably wouldn't be using integrated data viewer.
I probably wouldn't. Probably not a good idea. But for this kind of stuff, it's kind of fun. I can really overlay stuff and do some really nice stuff.
Oh, yeah, and you mess with a lot more data.
Yeah, exactly. All right, so boom. So that looks like my last image there. So that one looks like 1916. So you take 4 hours off. That's basically 316, six minutes ago. And theoretically, my surface obs are updating as well. Let me go back a little bit, see if I can get my surface obs to pop back on. Where are they? There we go. So here are some surface obs. Essentially, it looks like those are not updating. Hold on a second. I don't know what time those are. But the surface obs look like, yeah, that's about 17. So my surface obs may not be updating, but this was a little earlier today and nothing really exciting all that much. See some heavy rain over the central southwest coast of Cuba here. I can come back a little bit and you can actually see the wind field. I don't see anything that exciting in terms of the obs over Cuba at the moment. So they were only porting 26 knots somewhere near the center of the storm. So we'll see if they get any reports of even sustained tropical storm force winds, which can be an issue given basically data outages, power outages, and sparseness of surface stations near the center. It's a very small circulation, it turns out, and we'll see that in the pressure field here in a minute. But you can see some broad southeasterly flow over central Cuba earlier this afternoon, basically, and I can step that forward, and it looks like my surface obs are not updating. Looks like my last, so this guy here is basically 1726, right? So that was 1:30 today. I thought I set these to update. Well, here you go. Let's just wing it right away. But if I do this times, let me just see if I can get this to, I thought I had this data choosers. Watch this. Let's just do this field selector. I haven't done this in a while, so who knows what I'll break. But anyway, let me reload data and see what happens. I know this is a big mistake. I'm going to regret this. I mean, what could possibly go wrong, right, Cheryl?
I'm just waiting to see.
Hey, look at that. So there's 17. So that's good. So it looks like I have some more wind obs in here. So this is going to 1811, but they're not updating. Oh, there you go. So there's another update. These are hourly. So still southeast. You can actually start to see in here, guys. So salmon gang, you can actually start to see basically what appears to be the center of circulation in here, perhaps. So clearly have northwest flow here in these obs and southeast flow here. So, you know, if you gave me a choice here, this is kind of, you know, we got terrain too, so you have to worry about getting a clean wind field here. But you might push the, you might put the center of circulation basically somewhere in the region of where the 4 dots are, maybe. Okay, so just a heads up there, and see if I got a little bit more on here. Let me go move it forward a little. Okay, so that's as good. So what I have here, the last updates sometime around, at least I moved forward about an hour on that, right? There you go. So that's the jump. So those surface obs basically are 1831 minus, that's 230. So we haven't quite got the, I haven't quite updated yet. So the next hourly would come in, but it looks like the circulation's right over somewhere in this region at that portion of Cuba. So this is one presentation, no sense limiting ourselves to this view of the tropical cyclone. IDD lends itself to other cool stuff as well. So the wind field's unimpressive, clearly, but I can actually switch to basically, I can kill that and we can kind of go back and forth. And so let's take a look at the enhanced, I went and chose a color scheme. So this is enhanced infrared channel that for the most part, in the absence of clouds, would actually see down to the sea surface. So for those who will take my remote sensing class, I will be teaching it this fall. We can, I'm gonna go in and out basically, and then come back up here. And for those who will be taking that, I'll be talking about all this kind of imagery in that class this fall. I haven't taught it in a couple of years, so look out. I'll break something, I'm sure, as well. But anyway, I always find this very difficult. So let's just move you guys off to the side here. And so here we go. So I don't want to block it. And anyway, so this is the color scales on the left in degrees K. So freezing, you know, we're looking at, again, the infrared temperatures. So if you take a quick look at this, you can actually see, let me put it back some as well. There's Florida. Let me go ahead and just let it loop forward for you guys. There she is. So we have two main regions of convection. The center, this is the second patch to the south of Cuba is on the south side of the circulation. The center of circulation also has some pretty cold cloud tops. And if I stop this for a second and back up here, we can take a closer look at what those might be. Boom. So these are pretty cold. And if you sort of look to the left here, and these guys as well, we're looking at some cloud tops, I don't know, maybe somewhere around 200K, somewhere between, I would say about minus 70 and minus 80 degrees C, right, around 200K. So some pretty cold cloud tops there. And again, also, oh, I see, it was weird. I didn't really want that one, Control X. And then also basically, again, those are also kind of pink, but you know, you can look way away from the tropical cyclone as well, and it's not, some of our deeper convection, even if it's not cyclone related, can get that cold in the upper troposphere. It's not all that unusual. And so we're looking at obviously some other cold cloud tops from some thunderstorms to the east of the Bahamas here. Here's Florida up in this region as well. So anyway, really not all that impressive. If we had a really truly intense tropical cyclone, we might get as cold as minus 90. And so we might be down in this region. So nothing to really write home about as far as that is concerned. So that's sort of the satellite presentation. I like to kind of go back and forth. So I'll just take the time out if you guys don't mind. And let me also do this. I guess it'd be nice just to zoom in a little bit more. And in theory, that should be it should be okay, correct. So you can sort of see essentially some of the, maybe I should really do something crazy, but it's 24 images. It's neat. You can actually see some cool stuff on here. So there's Central Cuba while I'm at it and having so much fun. It looks like, look at this thing right here. That's a rope cloud. That's really pretty spectacular. So when you start seeing lots of these in the visible satellite image, it turns out oftentimes that's indicative basically of some dry air. Oh, it's updating. That's indicative of some dry air somewhere in the lower to mid troposphere. So you're getting some cold pool development outflow basically near the surface and a gust fronts. So you're essentially looking at a big gust front from the convection and it's elongated long enough. It's basically from essentially a fairly decent bit of convection for sure. There goes my wheel again. What did they say about my wheelhouse? Don't answer that one. Okay. Anyway, let's see here. Oh, I've got a rogue gust front now. Control me kill that baby. And he still has it. All right. That is really weird. And then oh, I see. It's still wheeling and dealing. So, yeah, really neat feature, clearly. And that would show up pretty warm in the infrared, right? These are shelfy like clouds. It'd be a great shot out there if you're in a boat looking somewhere looking eastward. Okay, so while that just rolls, I think I can still show you some more goodies here without a doubt. So let's do that and put you guys down here for now. I always never know what to do with these. I'm just gonna minus that. Okay, so let's take a look at the sea level pressure in the forecast. I'm gonna zoom back out here. And so that's not the one I want. Let's bring up mean sea level pressure. What the heck? And so here it goes. Maybe I broke it. Oh, cool. I better stop clicking buttons. And patience has never been one of my great virtues. Although Sam, you'd be happy to hear that I have mellowed some, although I'm sure some people would debate that. I know. Anyway, there we go. That's what I wanted to show you. Ain't that Char is purty. All right, so let me get rid of the geopotential height. So we are looking at sea level pressure. So gang in red, contoured in red, you can actually see 1,009 millibars analyzed here this morning. This is the GFS. I took the liberty of smoothing the pressure field. You can do that in the integrated data viewer. For those who take my my remote sensing class, and if I'm teaching it, I actually teach people how to use the integrated data viewer. I used to do it during weather briefing as well, but I've now Joel's been teaching that class, although I have offered to come in to do a workshop or two on IDV in there. So let's watch this baby. Again, this is Joe, this Cheryl, Sam, Cassie, and gang, Colin and gang. This is basically, this version essentially is a deterministic forecast, not an ensemble. So, and Evan and Fabian and gang. So this is the deterministic repeat. This is the deterministic, basically, the deterministic GFS global forecast system. So this is not the GEFS. The GFS is also run in ensemble mode. And that's where the GEFS comes in, where they actually do perturbations of the initial conditions or the model physics. And these little variations on a theme give you an idea of how well we might have an understanding of the intensity, which is not well done by these models, but at least the track for the most part. So again, this is the center line, basically, essentially the center line kind of forecast here. So this was 12 UTC today. And let me just move this down, I guess, push this back up here like that. All right, so let me go ahead and hit forward on it. So this is going in increments of basically an hour, because that's what I'm stuck for. Oh, there you go. This is why they call it the integrated data viewer. So there goes the overlap of the model forecast, basically, and the cyclone, which is kind of cool, right, Cassie? And then Dr. L is going to keep marching this through. All right, so now I'm hitting only model forecast column. So watch this baby go. So, all right, I'm leaving the observation window. So this basically is this afternoon at 19:30, which is right around now, 3:30 this afternoon, essentially, for the model forecast. This is actually a 21 UTC forecast, actually, this evening, sorry. So it's later on this afternoon. So this is around 5 o'clock today. And then this is jumping in 3-hour segments. So this is 8 p.m. tonight. This is, again, so this is 11 o'clock tonight. Again, deterministic. Should be basically 2 in the morning. All right. This should be 5 in the morning. And this is 8 a.m. So it emerges just southwest of Key West around 8 a.m., just after sunrise this morning. And that little small pisher of a storm basically is in the southeast Gulf of Mexico, around 15 UTC tomorrow again. So we're looking at around 11 a.m. tomorrow, right? And then 2 o'clock tomorrow afternoon, it starts to approach our latitude, and it just kind of hugs the west. It's pretty close to this deterministic track. If you look at the Hurricane Center forecast track, it's pretty close to where it takes the storm. So there is that little booger hanging off Tampa, basically around 0Z or 8 p.m. tomorrow. So it looks like to me, Sherry, Cheryl, Gabe, and gang. I like that, Gabe and gang. Excuse the alliteration. I like the fact basically that this looks like anyway the closest approach and the highest winds here will be sometime tomorrow evening around 8 p.m.ish. And then it's going to lift north of us basically. It is not a truly exciting pressure gradient. I read the local weather service forecast discussion. It is possible to get some gusts down to the surface that even in our region, although I'm minimally excited about really anything exciting. The tight pressure gradient, what little there is confined basically Tampa, St. Pete along the west coast of Florida as it reaches our latitude. Here we are obviously over on the East Coast, really outside. It's a small storm, okay? And so nothing really all that exciting. And then you can actually see as it goes into tomorrow night, basically a Tuesday night. And this is, sorry, I jumped back. This goes back one. So really, there you go. So that's as far as I got. So this is basically, this is 6 UTC essentially tomorrow night, right? So we're looking at about 2 a.m. essentially Tuesday night. Okay, so it starts reaching north of our latitude. It is going to be heading off to the northeast. So that's the GFS deterministic. Now I did promise you guys, so I don't want to disappoint. So let's go back to the 12 UTC GFS view of the sea level pressure here. And I sort of gave you the 101 on tropical cyclones. These are warm core systems. So I'm going to go ahead then, Sherry and Sam and Colin and Gabe and gang. I'm going to go ahead here, and Cassie, don't want to forget Cassie. Anyway, I see B Dud is on as well. Hey, B Dud. And Fabian, hi, Kelly. So what I'm going to do is I'm going to overlay, well, I don't want to get ahead of myself. Dr. L ever gets ahead of himself. So let me just go ahead. I'm actually going to put the isotherms on. So let me back up, though. I know I only have a little piece of it. So I'm going to zoom in on the storm here. So we're looking at sea level pressure, the view of it, at least in the GFS. And the Hurricane Center talked about some tilt or displacement of the convection and or the upper level core from the surface core. Sometimes it shows up in the satellite image, but I'm going to go ahead and put the isotherms on here. And interestingly enough, basically the isotherms I plotted here are 300 millibars. Let me plop this guy back off. I could always go forward a little bit too, right? Like that, you can see that guy move. So that is the manifestation of the temperature at 300 millibars. So again, I showed you that about 9 kilometers up in the atmosphere. This is the sea level pressure. Kind of interesting when you see the GFS view of this. I'm not saying this is the absolute view of the structure, but it looks like the center of the storm and the warm core are displaced aloft, right? Now think about this for a second. It's that warm core, right? It's the warm core, all that latent heat release that helps drive the cyclone and intensity. When these two are not correlated, I haven't looked at a lot of them. I just thought this was interesting today. You would think basically over that warm core is where the pressure falls, or under the warm core where the largest pressure falls would be ultimately. And so if you want a cyclone to intensify, you'd like to see these features stacked, right? You'd like to actually see that warm core aloft basically feed back into the reduction of essentially release latent heat. The pressures fall aloft and the winds accelerate into the center of the cyclone. If they're displaced, it's not a good thing. And so I do believe this is part of that structural issue that the Hurricane Center was actually talking about. I don't know for sure, but when they talked about an eastward tilt, Joe and Kelly and gang, I think basically when you look at this guy here, control, hold on, control X, wait. I'm thinking basically we're looking at essentially this little tilt here. Okay, so I thought that was cool and worthwhile showing you guys this. I could step it forward. I didn't really think about that as well. Let's just step it forward a little bit in time. And it looks like basically, can I do that? There we go. Yeah, it doesn't look like it gets any more correlated. And then, this whole thing's going to get disrupted. Let's take this through here, kind of nice. Let's see here. Kind of neat. I'm winging it. Sorry, guys. I'm known for winging it. That's why I get myself in all sorts of trouble. There we go. Yeah, it doesn't really look like, oh, it's not bad there. Yeah, it really doesn't look like this thing's ever going to get its act together, in my opinion. But don't quote me on that. Okay, so anyway, so let's kill off the temperature. And so finally, what didn't I show you here? What I didn't show you guys is the large, so let's back up, right? These systems, as they gain latitude, clearly interact, right, Kelly, with the westerlies. So let's go ahead then and take a look, Fabian, at what this baby's doing and what she's going to be interacting with. So I'm going to come back out and look at the large scale, and the large scale is still a problem. So in forecasting sort of the curvature and where these storms start taking more of a northerly and northeasterly turn can be problematic. Slight small error, especially in extended forecasts on the large scale, can have a huge impact basically of the eventual track of the cyclone. So timing issues, even when it comes to the large scale, which is fairly well resolved, can be an issue because, well, our forecast models are imperfect. And so even the large scale is an issue. So let me go ahead then and bring up, so I'm going to show you guys the about 5.5 kilometers up in the atmosphere. These are the geopotential heights. Basically, again, this is the global forecast system. This is at 12 UTC this morning. This is the large scale trough the cyclone will be interacting with. I won't put any wind vectors on yet. Let me just step this forward in time. And so I get my images are updating. I guess I can come back a little more here. Let's come out. So, so Fabian and gang, you can actually see kind of nicely. So that the main part of the trough here, is, it's giving me a bit of a hard time. Control S is sort of right here. So there's the mid-latitude trough, but it swings all the way back down into this region. They talked about some sort of, so that is that mid-latitude trough. Here is the manifestation of that pretty pathetic cyclone at 500 millibars. It's earned itself one closed contour. Woohoo! Try to contain yourselves. Sorry, Cassie asked me to brief on this exciting storm, and here I am chatting with you about it. So anyway,
when I asked you, it was exciting. But then it fizzled.
I must have missed that day. All right. So anyway, ultimately, that's the trough. It's interacting with Sam and Kelly and Brian and gang. And let me go ahead and clean that up a little bit. So that's 12 UTC this morning. And I can step this forward And it's kind of cool. There's a storm popping on. I like how it just does that. Nice little integrated. And now, of course, we're in the forecast. You can see this guy at 500 millibars making its way northward. There's still a residual trough. I guess, they always call these, Joe, you may hear this in the discussion of the Hurricane Center, a weakness in the ridge. So if I don't bore you guys too much already, I can just basically, this is the big ridge. That's the subtropical ridge at 500 millibars. The ridge axis basically is hanging this direction here. There's your ridge axis at 500 millibars, basically. And then essentially it looks like there's a little bit of troughiness here. They talked about, the Hurricane Center talked about this. They said this guy was going to be passing through that feature. So there's this little exit stage, right? I know it sounds like Bugs Bunny here. And then the ridge axis basically picks back up again at over here. So this sort of whole region here is that weakness in the ridge. The Hurricane Center is kind of talking about for better or for worse. This ridge axis is really important when it really comes, and this is only one level to rule them, and it doesn't rule them all, right? When you look at storm and tropical cyclone motion, you have to look at the depth of the troposphere. The more intense the tropical cyclone, the deeper you have to look, because it interacts with a deeper part, more of the troposphere higher up. If it's an intense cyclone, and then basically less so if it's a less intense or tropical storm. Anyway, this ridge is really important. And in the seasonal forecast, this is something basically, while we'll get numbers basically, it's hard to know really landfall, statistics of landfall, because our models are not really that great at predicting the intensity of this ridge axis. And it's obviously very critical when it comes to steering currents. So there's timing issues, there's locations of these ridge axes, the intensity. At one point, if you recall a few days ago, this storm basically, if we looked at the integrated sort of winds in the atmosphere, this storm was booking along at faster than I've ever seen it on the south side, basically, of this ridge axis. It was booking along at almost, was it 39? It was like 30 miles per hour. So that's about as fast as these things move. Doesn't mean there's any shear though. If it's 30 miles per hour over the depth of the storm, there's no shear, right? So if it's embedded in sort of a flow that's fairly constant with height and direction and speed, there's still no shear. Anyway, just a couple of comments there. So I think I'm pretty good there with that stuff. So, so I'll go ahead then and just toss in. So if you want to see what the 500 millibar wind field looks like, there she blows really. I can zoom in. So there's the 500 millibar wind field. And hold on, let me come back down. You're starting to see one thing about, I can make a couple of comments here. Let me go ahead. So you can actually see some pretty, oops, I didn't want to do that, but that's okay. So let me do this, minus, come back out. All right, that's good. So take a look. So this again these are the 500 millibar winds. Okay. So a couple of things here, Joe and gang. So I can actually see the anticyclone here. That's calling the ridge axis I was talking about earlier, right? So some nice anticyclonic flow around that baby. And I can actually see some northerly flow there. So, but here's the other interesting, so check this out. So there is some good southwesterly flow at 500 millibars, and our storm basically is somewhere down right in here, right? So this is going to be moving up in this direction, right? So there's going to be some pretty good southwesterly shear or southwesterly flow this storm is going to be encountering. So I didn't look at water temperatures for you guys, and got enough to show already anyway as I spin through this. But that's essentially a piece of the trough, the residual trough that's over the essentially western portion of, the eastern portion of the US here. Oh, look at that. It just shrunk my vectors. It's like I can start a new movie. It's not Honey, You Shrunk My Kids. It's IDV, You Shrunk My Vectors. All right, so yeah, I know, don't quit my day job. Anyway, so what can I say here? So that's kind of interesting as well. I don't, it doesn't bode well for the life cycle of this poor storm. This is 12 UTC, so we could sort of take it up and out if we wanted to. Let me just, there we go. Let's see what happens here on a zoom. Don't ask me to get the vectors back up. So anyway, you can actually see, it's kind of interesting, like what the heck is this, right? 500, again, this is 500 millibars. Here it comes up into that large scale flow. And again, you can actually see this is this evening here. And again, there's some pretty decent westerlies here. And if you want to be creative here, I draw some streamlines. You can see some basically westerly to southwesterly flow. And again, westerly flow here. And so this guy is basically, in an integrated sense, heading up in that direction, right? As it sort of impinges upon the westerlies. You might be saying, right, Sherry, Cheryl, and gang, what the heck are the westerlies doing this far south in the middle of summer in Florida? They do influence. Basically, they're obviously not as prevalent, and these winds aren't that strong. We're looking at 20 knots, right? Maybe at 500 millibars. So it's no jet streak, but there's still flow, and the storm's interacting with it. So anyway, I think basically, let me do this. I think that's about, I actually survived the IDV onslaught. So that's nothing short of a miracle. It wasn't too bad. I hadn't blasted out my window. I would have my browser. It would have been smooth. It's kind of scary. But hey, if I didn't, I would disappoint people if I didn't screw something up. What I didn't do, a couple of, just in case you guys want to know where Dr. L, I like a couple of sites. I had these loaded in my last browser before I killed it. Oop, anybody want to know how much time? Control tab, let's bring up another browser window. I mean, there's a bunch of places to get spaghetti diagrams. RAL NCAR is one of them, SSEC in Wisconsin's another. RAL NCAR, where did it go? Real-time guidance. I kind of like this guy here. It's really, you can do this on your iPhone, point and click. So if you want to look at ensembles, the RAL's not too bad. You have an early and a late cycle track guidance, and you can see how much the ensemble, and this is the sort of, I mean, people use different types of ensembles. You see how nice the ensembles here really tightened up. This is a very good indicator, right? That there isn't as much uncertainty anymore. If you remember a couple of days ago, Cassie, it was from Yucatan to the east of the Bahamas, right? So nothing like, generally, Kelly, when the time window shrinks, these things will tighten up, but not always, because there are certain external circumstances, changes in the large scale weather pattern or timing issues that can increase uncertainty even in short forecast windows. So, but this is typical. You'd like to think, right, Joe, that as the time window shrinks, that your ensembles and your forecast certainty certainly is better, but it's not no guarantee. So I do like this site. There's a ton of others we could spend. I'm sure you guys go to Tropical Tidbits, right? It's a really great site. I look at that on my phone all the time. I really like that one when I'm not playing around with IDV anyway. And Pivotal Weather is also a really nice site. And then I guess what I didn't do for you guys. So I guess I could do this, right? Control X. I like SharpEye. This is free software. So this is kind of fun as well. And I loaded the NAM. Let's see if it actually will move this. All right, let's see what happens. Yeah, I think NAM's giving me a hard, oh, there it goes. So I loaded some NAM soundings on, and so let me do this. So these are forecast soundings. So I'll wrap this up in a second, but since I went ahead. So this is free software. It's called SharpEye. So it's Python based, and you can just download the GUI. If you look for SHAR capital P little y. So if you look at SharpEye, basically look for SharpEye. This is open source, and you can download the executable. So it doesn't really take much in the way of installation as far as that goes. It's just a GUI, really nice, and it's a long history to this. So we're looking at a SQT log P here on the left, and a hodograph. Those are the ones I like to spend the most time on. And there is a slight tornado threat So when storm, we don't really get much of a tornado threat, it turns out, if you look at the climatology of hurricane spawn tornadoes or tropical cyclone, tropical storm spawn tornadoes, you don't get much in the way for cyclones that are moving from basically moving essentially along a latitude. So east-west or west-east moving cyclones. We get hit from the east here in Florida. We generally do not see, and we had Francis and we had Jean back in 2004, almost nothing in the way of anything. When Irma moved up the state, basically, we had a full day of little squid dancing around basically in the Atlantic and lots of little mesos rolling on shore. So basically tropical cyclones moving from south to north in our anywhere in our region, Gulf of Mexico, tend to produce a lot more in the way of tornadoes. And I've read several discussions. It's beyond the scope of this discussion. So anyway, one way to gauge the sort of nature of the beast is look at photographs. For those who are not familiar with photographs, it's a polar plot here. This is the wind profile. Again, this is not from sounding data. This is from the North American mesoscale model. This is forecast. I actually grabbed about 5 soundings out of the NAM that are valid tomorrow when things get interesting, as that tropical cyclone makes our latitude, where we might have the best wind field, quote unquote, you don't quote Dr. L, calling the best wind field the wind field that will produce damaging tornadoes. But anyway, that's the way my geeky mind works. Bad weather is good weather. So the best wind field for producing horrible weather like tornadoes would be probably around tomorrow evening sometime. And so this, let me back it up. This is a 36-hour, and let me click on this for a second. 35, 34, 33. This was from this morning's 12Z NAM. So if you look at this guy up here, the forecast cycle is right here. And then the basically forecast time, 33 hours out. So this is tomorrow afternoon. It's 24 hours plus 9 hours, right, after in the morning. So we're looking at tomorrow afternoon, right? You can actually see, Kelly, the wind field here. Oops, Control X. So here is the wind field that's forecast. It's classic tropical weather, not mid-latitude cyclones, because if you look up here, we got no winds aloft. This is nothing. All the interesting stuff, Joe, I see like a 50-knot wind down here. Not unusual. And so that is consistent. If you look at this little guy here, this is the wind profile with height, which is kind of cool. This is a classic, basically tropical system wind profile where your winds actually peak. This is great. I thought this is worthwhile also, where your winds actually, let me do this again. All right, Control S. You can look at this right here. So this wind peak here around 3 or 4 kilometers really is essentially this wind speed here, showing up here in the profile. And so what's important, and this is, let me make one last point before you guys go to sleep on me. Here's the cool thing about this. So you can imagine if Dr. L gets really creative here, you have deep convection. Here's Dr. L's little anvil and thunderstorm basically, and it's raining down through this. So one of the key players in transferring momentum to the surface are these downdrafts that basically pass through these just slightly above surface wind maximum, these tropical cyclones. That's why when you get a squall through, the winds suddenly pick up. You're bringing the momentum down to the surface basically, and then of course the squall passes and the winds relax to whatever essentially the background pressure gradient, plus or minus. Okay, so that's really cool. And again, I could remind you, you guys can see that profile in there. And then I could always come back to this figure to show you basically there on this little cartoon diagram. This is the cartoon picture of that very wind profile that I stole from pretty much the standard wet met text on tropical cyclone structure. And you can definitely call in and gang, see that wind max somewhere, but it's slightly different. The z-axis there, but that's somewhere above the surface, maybe around 2 or 3 kilometers above the surface, maybe a little lower depending on the cyclone structure and intensity, beyond the scope of this class, or this. See, I'm talking about class. That's a habit. Sorry, but hey, whenever I get a chance to give people a little insight. Why not? So anyway, I digress. So this was basic. This is tomorrow afternoon. Let me hit the forward key on it, and let's watch the photograph. So let's watch this guy up here, evolve or devolve. I don't know. What are you looking for in a photograph? I'm not teaching weather briefing now, but you're looking for curvature. So in the low levels. So for those who, this is kind of cool. I should do this. Watch this. Let me put my readout cursor on this one. So watch what happens. Watch don't watch my, that's like pay no attention to the man behind the curtain. It's like the Wizard of Oz here. Don't pay attention to my arrow, but watch the photograph. And you can actually see that if I start in the lower part of the troposphere, the winds here are south southerly, and then they go basically to more southwest, southeasterly, then southerly again, then southwesterly, and watch it as I go up the profile here. This maps out those winds. Isn't that cool? So you can actually see me mapping out. It's these winds over here that are being mapped out on the photograph. For those who don't know how the photograph works, basically you just draw a vector to the photograph line. It's a parametric curve representing the winds at each level. So there's that level, there's that level, there's that level, there's that level, there's that level. Do I sound like a broken record? There we go. Sorry. And so there goes another wind vector. There goes another wind, and then you just connect the tips, basically Fabian and Gabe, and voila, you have a photograph. It's a nice pole. These are really cool. And so if you look at all my vectors, all I've done is mapped out the directions and wind speeds. If you look really closely on this figure, you'll see these concentric circles, basically. So it is a polar diagram with wind speeds basically on the respective axes in knots. And so what can I say? There are a bunch of numbers here on the left-hand side. Those who've taken my dynamics class in the past, right, Sam, will recognize some of these guys in here. These two rows, basically storm relative helicity, are fairly decent indicators of essentially tornadic activity. Nothing's being flagged here, not at least on this profile here. If I march forward, let's see here one more time, boop, and that is 36 hours. Mean wind, I'm looking at the values, really nothing to write home about in the NAM. So there you go. Now we're starting to get up to numbers here from the surface to 3 kilometers, some basically potential to rotate. And again, that is a 32-hour forecast. So basically that's, what is that? I wish they would actually put the time when this is valid on there. You have to do all the math here to figure this out. Oh, it's 20 UTC, I see it, sorry. I'm blind. So if you look at this guy here, that's 20 UTC basically tomorrow evening, right? So take 4 hours off of that, right? Correct, for our time, and that puts us basically at, it looks like essentially, right, that's 20, is that really 20 UTC? I didn't go very far out, did I? So it looks like that would be 20 UTC, right? So that you take 4 hours off of that, and that's gonna be 16 UTC, all right? So we're looking at around 4 o'clock tomorrow, okay? And I don't know, do I go any further here? 33, that's 5 o'clock tomorrow, and it looks like, if you look at this, right, that's going into the evening. The NAM's not too excited about after that. So the best wind field, according to the NAM anyway, is sometime afternoon, a small window around 4 or 5 o'clock maybe, that has some decent. So if we get to decent convection firing, we are on the right side of a northward moving tropical cyclone. There could be some tornado warnings tomorrow. That might be the only show in town. Okay. So I'm going to stop the share. Sounds like I'm saying something else. But anyway, well, that was probably more than you ever wanted to know about an anemic storm. I apologize. I try to make it as exciting as possible, but you know how that goes. I'm at the mercy of the weather. So I see a couple things in the chat. Oh, bring me back to dynamics. Okay, Sam, yeah, yeah, you should have seen all the students that had to take the exams online. Can you imagine taking my dynamics exam basically online? You can talk to Colin about that one. And then basically, see, and then Colin, the NAM also can't decide on a storm motion. Well, they're only guesstimates anyway. You notice how I say guesstimate, not estimate. So yeah, there's a standard way of going to get a storm motion. Obviously, if you have radar data and you can actually watch the storm moving, you can put your own storm motion on the photograph. That's the one that matters, not the forecast storm motion, but the actual one, right? And you can get a bunch of them in the same environment. So anyway, but I digress. Stay tuned for dynamics. No matter how you spell it D-Y or D-I-E.
I have to.
Same as laughing.
I don't want to.
Yeah, well, it's not Dr. Oh, and then I wanted to show Professor Split generated this one. So I asked him to do this. He actually used a tool called Hervac. We've been helping the president of the university forecast. So this is a product, they use the NHC. Oh, we can't see now. I'm no longer sharing. Hold on.
About that.
Yeah, like I said, I don't get out much. So anyway, let me minus this one. Well, I can't wait to shut all these windows. So here's the official Hurricane Center the latest advisory at 2 p.m. You can actually see that up here. These are wind speed probabilities, cumulative probabilities. Wind speeds in blue, yellow, and red here. You can see 14%, 0%, 0%. These are, again, cumulative probabilities of blue being basically minimal tropical storm force winds, 34 knots. The yellow are strong tropical storm force, 50 knots, and hurricane basically are red. And if you can sort of squint, you might be able to see the much higher probabilities. I see 40% up here near Gainesville. So clearly, and then you can see the 50 knot in goldish here swath, and then the 34 knot. So I'm not overly excited about much of anything. Whatever little, if you guys want a road trip and go west, probably not that interesting either. You can certainly head to the Tampa Bay region and whatever. And you can see these are it's not a hurricane, even at our latitude. It may undergo some re-strengthening in the Gulf, but with that southwesterly shear, just don't know. But you can see 65 miles per hour. It's slightly under hurricane force. So sorry. Now I promise you I've stopped the share for the last time. So Gabe, you have a hurricane going on in the background, probably more exciting than Elsa. Any questions for Dr. L? Comments, criticisms, apples, oranges, eggs?
I think it's a little unfair to call it boring. I know you can't every day you have a Cat 5 rolling past, but
Why not?
Yeah. And boring is better, but it is not exciting if it's not an intense storm. So,
right. Yeah.
Oh, well, that's the reality of it. I'm sure people in general are happier as well. That I will be. I guess that's the one upside is when there is a bad storm, you do get to be excited as a side effect.
Right. Or you could just be the Weather Channel and get excited about this one.
Yeah.
They get excited about all of them, honestly.
Yeah. So
Well, they're privately owned now.
They are interesting. So you notice that climatology I showed you, warm core, right? We didn't look at, I forgot to show you, I did show you the isotherms around 300 millibars. It was, if you looked at the difference of that inner contour of those isotherms, I forgot, it's because I fly through this stuff, sorry. If I'd shown you, I could have proved to you it was definitely cooler out. Those isotherms that away from the center of that storm, basically at 300 millibars, were definitely cooling. So just take my word for it, Scout's honor, I swear. The other thing I was going to say about them is that if you looked at the temperature perturbation you went away from that storm at 300 millibars, it was about 1 degree C, which is consistent with that climatology I showed you for tropical storms. You know, the Cat 5 had about -10 to somewhere between -10 and -15 on average climatologically perturbation at 300 millibars. If you looked at the tropical storm one, it was 1 or 2 degrees C. So not much of a, it wasn't impressive in many respects. But so Joe, I'm running the antithetical media anti-hype today. So if you need somebody to do that, bring you down to earth or something like that, just give me a call. I do that to Cassie all the time.
It's true. He does.
You're running a vibe check on people getting too excited.
Yeah, let's save it for the good stuff. But it is weather at least.
True. At least there's something to look at.
Yeah, and hopefully we get a couple of squalls come through here. So
Well, yeah, that's why I got confused. I was going to go down to the site today. I was like, maybe I should wait and see what the forecast is.
yeah, I
Oh, we're
didn't.
close.
Did you guys look at the, I was gonna look at the radar real quickly out of Key West, see if it's even worth showing. It was not very exciting the last I looked. So let me single image, so only do 2 hours maybe. Hold on a second. If it's worth showing, I'll pop it back up. Oh. So yeah, you guys you want me to share a screen one more time? What the heck? Oh, I got,
Yes.
there's five things in the chat now. All right, hold on. So since we're geeking out, let's just do this. Yeah, every time I say it's the last share, don't listen to me. All right, so anyway, it sounds like a song though, the last share. All right, anyway, it all sounds like a song to me. So you can actually see there's that, there's that satellite presentation of that feature, that rogue cloud. It's dissipating or moving, at least, well, it's dissipating. Be careful. It may not be. We should look at a satellite image. It's moving away from the Key West radar. If it happens to be a shallow feature, the Earth's curvature bends below, right? The beam's curved, overshoot it. So I would have to look at a satellite image. At this point, though, you can actually see that feature. It's pretty nice. And then since we don't get access to the Cuban radar, we're stuck seeing this guy down here starting to emerge. Obviously, he's got a ways to go before it comes out. But this is at least current, right? It's up to almost 20 UTC, right? So that's 4 o'clock. I saw that, Gabe. So anyway, yeah, so here's the sort of main portion of the storm. South Florida's already getting some pretty good fetch of some deeper moisture. And it looks like it's getting ready to storm here as well. All right, maybe this was the last time. I don't know. I'm currently a good liar. Let's see here. Stop share, there it is. All right, I swear I won't do that again. Okay. Oh, now it's up to 7. What happened to my chat? So what else got said? Let's see. LOL. Oh, Cawthor's on. Hi, Cawthor. Elsa memes are my life now. Hey, OMG.
You're going backwards.
I know.
I assume we're talking about.
But I always go backwards.
Fair enough.
You ever it's like dangerous to read email, really dangerous to read, because otherwise you end up responding to something that's already gotten taken care of.
True.
So when you get thousands of texts and emails basically from folks, it's always best to start backwards.
I felt that in my soul.
Issued. I'm just saying, did somebody say something? Yeah, one of my friends in Miami has had a tornado warning issued already. Okay, cool. That was from Sam. And then Cheryl said Brian McNulty in Miami had some good Cuba radar views on his site. Nice. So maybe he's got a Cuban connection. I don't know. That's nice. And then Cawthor is laughing. Stop that. And then let's see here. Yes, we did that. All right. So am I good, Joe? You're okay with me going backwards then? You only, right? And then somebody said, let it go. Oh, that's Cassie. She likes a lot of O's, or key got.
What do you expect? Elsa is the name of the character in Frozen. You know it's my favorite movie.
Yeah. I got several. I got several of the same images. Apparently, there's that's been floating all over the place. Yes. So Ryan Kutro sent me one. Somebody else sent, and Mike's brother sent us one. So yes, I'm very much aware of that. Elsa's some other kind of character from Disney.
A good job of letting itself go. Doesn't seem to be organized very much.
So anyway, I spent a couple hours pulling up all this stuff. Hopefully you guys enjoyed it. I don't know.
Yeah, well, it's interesting to see because, if anything, it just gives me more tools to look at, to either look at it myself. And it's funny because I actually just did, Cassie and crew have set up a bunch of med-eds for the broadcasting people to kind of review topics. And I just went through some of the remote sensing stuff today. So
Nice.
it was a nice little sort of refresher to get right into understanding what you were explaining. I wouldn't have known what a lot of it was.
Yeah, well, I mean, I sort of I won't,
Right. I mean, you don't have
I-
time to
it
go
was
into
still-
a full detail on how, satellite and infrared sensing works.
yeah, I mean, it's still a bit superficial, but what can I do in an hour, right? Sort of just
Yeah.
give it at least I didn't, yeah.
But no, I found it very interesting because I had a little bit of the background to kind of look more in depth at what was going on instead of just being here and sitting and nodding like, okay, stuff is happening.
That's okay, a bobblehead doll works.
Oh. Thank you for taking the time to put that together.
Yeah, thanks.
worries.
That was great.
Yeah,
Thanks,
no,
Dr. L.
no problem. It was a pleasure. Hopefully next time I do it, it'll get a real storm. So,
They're going to be
Finger-
throwing
fingers
shade at
crossed.
Elsa till it's gone.
am I still on? Oh boy, I'm in trouble. I'm still on recording. Anyway.